Hi everyone. Here we're going to focus on the intensity of pressure and total pressure that's brought to bear on the base of a tank. In this video we'll firstly explain what intensity of pressure is and do some calculations on that, and then we will go on to calculate total pressure. Intensity of pressure is the force against a unit of area. Now, in this lesson, we will focus on the force of water against a unit of area that is 1 square meter. For this part of the lesson, we shall use a tank shown on the right, which has an internal base area of 1 square meter, which is shaded there in green. So let's go through the steps required to determine the intensity of pressure at the area of contact. Bottom of this tank uh, is 1 square meter as stated previously. So we will start with a tank whose internal measurements are a meter wide, long and deep. So this tank filled will represent a cubic meter of water. The depth of water here is referred to as head, by the way, which means that vertical distance from the surface of the water to the base or pressure point as animated here. If its head is exactly 1 meter, it's a known fact that it exerts a force of 9.8 kilonewtons per square meter. However, if its head differs from being a meter, then you will have to apply the following formula as coming into the bottom of your screen here now. Here we're going to reduce the depth or head of this tank from a meter down to 520 millimeter as animated here now. So if its head is, for example, 520 millimeter, then we must calculate using the known factor that we've already discussed, which is that 9.8 kilonewtons of force comes to bear on a square meter. And that's the force that would be coming on it if it were 1 meter deep. So there's the formula again that we will need to be able to apply, shown with an orange background. So if we want our answer in square meters, before we start, we must convert everything into meters. So for instance, that 520 millimeter head distance there will now become 0.520. So now we'll multiply 0.520 meters by 9.8 kilonewtons, and your answer will be 5.096 kilonewtons. So this tells us that 5.096 kilonewtons of force is exerted on 1 square meter if the head to the base is 520 millimeters. So to recap, we have discovered that a base of a tank will have 9.8 kilonewtons of head pressure on a square meter if it has a head of 1 meter. Using the formula head multiplied by 9.8 equals kilonewtons per square meters. So we were then able to determine what pressure was brought to bear on a square meter if the head was less or more than a meter. So using that formula on an example which had a head of 520 millimeters, we discovered that 5.096 kilonewtons of force is exerted on 1 square meter. So now that we have established intensity of pressure per square meter, let's go on to calculate the total pressure. In this next example, the tank has a head of 700 millimeter, and so its kilonewton per square meter is calculated as being 6.86 kilonewtons per square meter. This value will now be used to calculate total pressure as animated here now next. So here we have the intensity of pressure calculation first shown here on the side of this tank. So we've established that per square meter we have 6.86 kilonewtons if it is a head of 0.7 meters. So now that we have that information, uh, we're going to have to find out what is the area of the base of this particular tank. So we've discovered there that it's 0.36 square meters. So once we've got that information, and along the bottom there on the tank you'll see written, we multiplied 6.86 kilonewtons, uh, which is what it would be if it was a square meter for that head of 7.7 meters, I should say. And we multiply that then by the base area of this tank. And as you can see there, we got 2.47 kilonewtons. So let's just quickly recap here now on total pressure. We calculated the force of 6.86 kilonewtons on a square meter for a head of 700 millimeters. And because the area of the base of this tank was less than a square meter, we knew that the K in value would have to be less than the above stated for a base of 1 square meter. So we use the above K in factor per square meter, which is 6.86 K in, for this tank and multiplied by its base area, which was 0.36 of a square meter. The answer told us that there would be 2.47 kilonewtons of force on the base of this tank if it had a head of 700 millimeter. Okay guys, hope that's of use.